So currently we are used to buy stuff on the internet. We use, in Italy we use Amazon. We buy some goods and after a while when we return to the web pages, they will suggest us any new goods that we might be interested in. And for doing that, they try to match what I have bought in the past with what other customers have bought in the past. But they have millions of customers, so there is millions of data that must be crossed together to determine which are the goods that I will more likely buy in the future. Okay? So, in order to be able to provide this matching and suggest me with the things that I might be interested in, they have to do a lot of computation. And this lot of computation can only be carried on in a reasonable time if it is parallelized on a lot of servers running a smaller piece of this application at the same time. Now, we can use parallel, but the more things we do in parallel, the more energy we are going to consume. And if we missize the number of machines we are going to use, we overestimate them, we will waste a lot of energy and consume a lot of resources and pollute our planet. So it is very important to be able to determine exactly which is the minimum number of computer I need to provide an answer in a reasonable time without overestimate them too much. And math can help us in that. So some of the current applications of my research from a mathematical point of view are in sizing large infrastructure, reduce the energy consumption, optimize the internet connection, make sure that when we browse with our mobile phone we can exploit as much as possible the Wi-Fi so that we don't spend too much of our internet budget, but we have a reasonable service, so have a trade-off between how much we are going to spend for our service and the quality of service that we have. But there are also some other applications. For example, this type of math can also be used in medical application, in biological application. For example, they can also be used to model how a tumor will expand in our body and try to see if we start using some sort of prescription in a given point of time will help in reducing the spreading of the injuries. So there are a lot of potential applications. The name might seem very strange, but it can be tailored to many things, because mainly what I do is find a mathematical language which describe real phenomena and use them to quantify how things evolve during time. This type of models are models in which we have actions. Actions require some time to be completed, and there are a lot of things going on in parallel. So this type of mathematical models study are well suited wherever we have a lot of agents, as we call them, that interact together, and we describe how each agent behaves, we describe how many are done, where they are, and if there is some connection from the position where such agents are and how they interact. For example, one of the things we have studied was fire propagation in the wilderness. We modeled all the terrain in a forest. Of course, in the forest we might have area where there are a lot of trees, so that they are more susceptible to fire, but we might have river or lakes or rocks area where fires doesn't spread equally well. And so what we were able to do with one agent, describe one piece of location which can be normal, so nothing's going on. It can be unfortunately on fire, and if it is on fire it might spread it to the neighbor location. So the agents, which represent one small part of the forest, by itself will not do anything, but when the neighbor are on fire, might catch fire, burn for a while, and when the fire has extinguished everything, stop burning, but everything being destroyed. And we use that to model also a sensor network that tries to identify when there is the fire, and its goal is to propagate the message that something bad is going on as quick as possible, to where people can take action to stop the fire taking into account that fire might destroy the sensor as well. And so it must find the best route that can still reach what is called the base station, where people can have the information that something unfortunately is going on. I have applied into biologists and they are starting also to applying for studying propagation of news. We have all heard in the last few years the propagation of fake news that have, for example, led to the election of Trump because people were influencing each other with votes, with idea which might have been wrong, but a wrong idea could spread and change the behavior of the population. So other people are trying to use this type of mathematical tools also for analyzing this type of social behavior. So every day I have to face the application, since working as a mathematician in a technical university means that you have to convince people, which is more tailored to the application, that math is also important for them. First of all, my main problem is that Milano is a technical university, the one where I work. So most of the people is interested in the application of the math, but in order to be able to address this application, there are many mathematical problems that need to be solved. We will write equations, but those equations are not always easy to be solved, so we will need some expertise from mathematicians. So in Polytechnic of Milano we have all the experience for the applicative area, but there are not that many students who are interested in working in the mathematical side. They are good mathematicians because you cannot be an engineer if you don't apply math in a good way, but they like the application, not the math behind. And so for them is always asking to do some extra work in an area that is not their main focus to reach what is their main goal. So for me it would be really interesting to have an opportunity of a cooperation with a more scientific university which is more on the mathematical side, because it can help to solve all those issues which are not interested for the people working at my university, but are required to be able to apply this type of techniques to what they do. I think there must be passion in mathematics, and so usually you like mathematics if you find a good way of visualizing what happens and understand how your computation, all the calculation that you do can have an impact on what you're doing. For some people this is natural, for some other this is not. The other essential aspect is not be too abstract, because unfortunately mathematicians tend to solve some abstract problems. So for example, in some cases for a mathematician what they study is whether a solution has a problem or not. And maybe that solution will have a problem 99.9% of the times. Only one times every 1,000 that solution cannot be found. Of course, it is really important to know that, because if that case study you are using is that 1 over 1,000, you have to know what's happening and be able to identify it and tell, okay, no, we cannot use this, we have to find something else. But there are 999 other things where this is not important. So usually the mathematician might focus just in that 1 over 1,000 case.